The universe holds many mysteries, and some of them could pose a direct threat to our world. If we were to detect a massive object heading our way with only a month or two of warning, there would be very little we could do to stop it. Events like a nuclear disaster, a global pandemic, a chemical catastrophe, or a massive asteroid strike all share a common outcome. They lead to widespread chaos and the collapse of social order. While it remains incredibly difficult to find planets beyond our solar system, astronomers have now confirmed the existence of over 1,000 exoplanets orbiting distant stars. By studying the cosmos, we can gather crucial information to help us prepare for potential dangers. However, if a catastrophe forced humanity to seek refuge underground, current shelter capacity is severely limited, accommodating only around 6,000 people. This raises a critical question: what would everyone else do? We use powerful telescopes to scan our galaxy and these newly discovered exoplanets, searching for signs of life. Contributing to this monumental task, even in a small way, is a profound responsibility. In the final chapter of this exploration, we delve into the future of our universe and our place within it. We meet the dedicated guardians who watch the skies for any danger that could threaten our civilization in the coming decades. Can underground bunkers truly protect us from a global catastrophe? What are children's thoughts about the future of our planet? What incredible secrets will the largest telescope ever constructed reveal? We visit an observatory in Spain committed to tracking potential threats from space, as a future impact could mean the end of our world as we know it. Let's check what's on the schedule for tonight, considering the sky has been surveyed extensively this month. The focus here is on detecting asteroids and other near-Earth objects. Tonight, we might try observing from a different vantage point. There are still areas of the sky left unsurveyed this month, and those are where we should direct our attention. This location boasts some of the darkest skies in continental Europe, rivaled only by sites in the Canary Islands. Situated in southeastern Spain near the Mediterranean coast, it's close to another major astronomical center. The primary goal is to find near-Earth objects, most of which are relatively small rocks, ranging from 100 to several hundred feet in diameter. They can be detected millions of miles away, but because their light is so faint, exceptionally dark skies are essential for the contrast needed to spot them. The level of danger from these objects depends on two key factors: their size and our response time. A larger object obviously presents a greater threat. However, even a smaller object could be manageable if detected 6 or 7 years in advance, giving us time to potentially send a mission to alter its course. Conversely, a large object discovered just months before impact would leave us with no viable defense options. This work represents the first critical step in a larger process: detecting these objects, calculating their orbits, and ultimately developing ways to deflect them. The team is involved in the entire chain of operations. The initial phase involves detection using specialized optical telescopes. Standard astrophysics telescopes with large lenses are not suited for this task. They are not agile or fast enough to scan the vast areas of sky required each night. Instead, telescopes with a wide field of view are used, similar to a camera with a broad-angle lens, allowing them to capture images of nearly the entire sky in a single evening. These telescopes are operated remotely from a control room, but they can also be managed via the internet from anywhere in the world. This flexibility allows the observers to work from any location. Given the need for a rapid response, constant vigilance is required. Since you never know when a new object might appear, the team must be ready to input data and analyze findings in real time, whether they are at home, on a train, or even on vacation. A specialized graph shows which parts of the sky have been surveyed each night by international teams. At the start of every month, this chart is blank. Once the moon's light fades, teams begin searching different sky sectors. The mission for tonight is to concentrate on the areas that remain uncovered, as these offer the highest probability of discovering something new. Priority is given to the plane of our solar system, where asteroids and other near-Earth objects are most likely to be found. The basic method involves taking a series of images of the same patch of sky over a period of time and then comparing them. Stars remain fixed in position, but any object much closer to Earth will appear as a moving dot against the stationary background. What appears on the screen is similar to images found online, showing how a near-Earth object detection is confirmed. Small squares display sections of the original image, with red circles sometimes highlighting an object's trajectory. If an object is moving at high speed, the stars will appear as single, unmoving points, while the object itself will have shifted position, often leaving a faint trail. This indicates a very fast-moving target. It looks like a detection has been made. You can see it here and here. In one image, it resembles a small star, and in another, it looks different. On February 25, 2012, an object was found that clearly had the characteristics of a near-Earth object. It was reported to the relevant astronomical center. At that time, it was unknown if it would actually come close to Earth. After several days of tracking, its orbit was calculated and found to be very similar to Earth's. It was predicted to make an extremely close pass in 2013, coming within about 160,000 miles of our planet. While that distance seems vast on a human scale, in astronomical terms, it is alarmingly close. By mid-2012, it was identified as a very large object, estimated to be about half a mile in diameter, large enough to survive atmospheric entry and cause significant damage. Since records began, no near-Earth object of this size had been observed approaching so closely. An animation illustrates the event. The Moon's orbit is shown, along with a ring representing geostationary satellites. On February 15, 2013, the object approached rapidly. It passed near Earth's south pole, coming closer than our own satellites with a real risk of collision. The point of closest approach was over a dark zone roughly corresponding to Indonesia and the Indian Ocean before it moved northward. Had this object impacted Earth on that date, it would have torn through the atmosphere in seconds, creating a crater nearly a mile wide. A massive amount of material would have been ejected, and everything within a 62-mile radius would have been utterly destroyed, enough to wipe out a major metropolitan area. Because the observatory telescopes are operated remotely, the lead scientist can be alerted to new discoveries wherever he is, even while at sea. Sailing is a frequent pastime, with summer trips to nearby islands. On February 23, 2012, after a night of sailing with friends, the routine check of the portable computer revealed the detection of that significant asteroid. This incident underscores the need for constant connectivity. The initial detection of a near-Earth object is always thrilling, as very little is known about it at first: its distance, its path. That particular evening, during a fun gathering with friends just before sunrise, the exciting discovery was made. This work is deeply personal and fulfilling, knowing that one is contributing, however modestly, to a larger vital mission. The ultimate goal is to prevent an extinction-level event for humanity or a devastating impact on a populated area or coastal region, which would result in tremendous loss of life. In a way, this job is like being a hunter or a fisherman of the sky. It differs from other astronomical observations because it requires permanent alertness, akin to being in the trenches. You never know when an asteroid might approach, and obstacles like moonlight or clouds can hinder the work, making it a strategic game of detection and pursuit. A visit to a private company in the United States reveals the construction of high-tech underground bunkers designed to withstand any potential global catastrophe. For the last 5 years, the focus has been on building as many shelters as possible, as large as possible, in as many locations as possible, to save as many people as possible. Currently, shelters exist or are under construction for about 6,000 people, which is roughly 1 in a million. While that number is significant, it barely scratches the surface of global population, raising a troubling question. What would the other millions of people do if a disaster struck that made the surface uninhabitable? Events like nuclear war, biological agents, chemical attacks, asteroid or comet impacts, or massive geological upheavals all lead to the same result. Anarchy, where law and order break down because governments are incapacitated by the scale of the crisis. If survival necessitates going underground, and only a tiny fraction can be accommodated, what is the plan for everyone else? The solution offered is a turnkey shelter containing everything needed to survive underground for up to a year without returning to the surface. Occupants would be sealed behind blast-proof doors with nuclear, biological, and chemical filtration systems, protecting against pandemics and warfare agents. The shelter is stocked with food, clothing, toiletries, and all essential supplies. A new shelter in Kansas, begun recently, is located in a giant, pre-existing limestone mine. It's not deep or round, but flat, measuring half a mile long and a quarter-mile wide, with a total area comparable to the Empire State Building. It can comfortably house 5,000 people and is the largest private shelter on the planet. Interior work is currently finishing. The most remarkable aspect is the cost reduction achieved through the site's size and construction method, lowering the price per person to about $6,000, a reduction of nearly 90%. Consider an event like a confirmed asteroid or comet impact. We are aware of one asteroid set to pass very close to Earth in 2029. Sitting here years in advance, we have nearly 2 decades of notice. Could you reach a shelter in Kansas in that time? Certainly. Space agencies worldwide are tracking this object. Current calculations suggest it will narrowly miss Earth, but it will return on another close approach in 2036. The aftermath of any major impact is uncertain. The worst-case scenario, a scorched Earth with a destroyed atmosphere, is possible but not the most probable. The more likely outcome is that the initial catastrophe will subside, allowing survivors to return to the surface, begin farming again, rebuild society, and hopefully create a better future. A journey to Bogotá, Colombia, explores what children think about the future of our planet and the universe. Is it as catastrophic as some envision? What are their dreams for the coming decades? With the discovery of new planets, many children believe life likely exists elsewhere. They find it hard to accept that in a universe billions of years old, Earth is the only planet with living beings. They imagine other life forms, possibly with more advanced technology and intelligence. Some think aliens might look similar to humans but more evolved, while others picture strange physical appearances. The consensus is that we are probably not alone, and there is likely great diversity in the cosmos. Some recall hearing about potential for life on Jupiter due to its great red spot. When asked about careers, many express a desire to become astronomers, captivated by the secrets of the stars, or aerospace engineers like those at NASA. Some are already amateur astronomers, fascinated by how constellations reveal history. If Earth were destroyed, ideas for survival include going to Mars and building a domed city to contain oxygen. Others would first search Mars for signs of life and water, looking for the same fundamental necessities we have on Earth. Establishing a base on Mars would require a reliable oxygen supply, large amounts of food, and adaptation to harsh weather conditions. The idea of leaving Earth to explore other worlds and see different types of animals is exciting to many. They acknowledge that the sun will eventually die, but that is far in the future. The immediate concern is taking care of our planet now, as the ozone layer thins and many species die. If current trends continue, they fear that in 50 years there could be nothing left. No planetariums, no cities, no countries. Throughout history, Mesoamerican cultures like the Maya had a rich tradition of observing the stars. Is this connection to the sky still alive today? What form will these ancient traditions take in the future? To find answers, we visit the most modern optical observatory in Mexico. Located at the National Astronomical Observatory, the site houses a large telescope and offers stunning views of the surrounding mountain range, forest, desert, and sea. This location was chosen for astronomy because it is far from city lights, providing dark skies free from light pollution. Such pollution makes it difficult to see faint celestial objects, much like trying to see past a bright light bulb held close to your face. In 2010, a law was passed to protect the night sky by making urban lighting more efficient, ensuring light is directed downward instead of wasted shining upward. A researcher at the Institute of Astronomy typically spends 5-day shifts at the observatory. On this third consecutive night, the team is observing a cataclysmic variable star known for its eruptions, where it suddenly brightens and then fades. They plan to monitor it for 20 nights straight, though the researcher, due to his age, limits his continuous observing time. The resident astronomers are responsible for supporting visiting scientists and calibrating the instruments. The most important telescope requires thorough checks before nightfall, ensuring it can move freely without obstructions. This powerful instrument can observe a wide variety of celestial bodies. Nearby stars, distant stars, faint objects, galaxies, nebulae, and planets. Another telescope on site is robotic, allowing it to quickly point toward areas of the sky where sudden explosions like supernovae might occur. The observatory has 3 main telescopes of different sizes, with more projects in development. The primary advantages of this site are the exceptional quality of the sky, which has been extensively studied, and the breathtakingly beautiful landscape. There is great pride in being able to work in such a magnificent environment, surrounded by natural beauty and a rich historical heritage. The Atacama Desert is another location with extraordinary conditions for stargazing. Here, the largest optical telescope in the world is being built, promising discoveries that could revolutionize our understanding of the cosmos. The site is south of the city of Antofagasta, in a uniquely barren landscape that resembles an uninhabited planet. It is an iconic area in Chile, close to existing world-class observatories and the future site of an enormous new telescope, currently in the planning stages. One of humanity's greatest challenges is to understand if we are alone in the vast cosmos, the only intelligent beings, or even the only life, in a universe containing billions of stars in billions of galaxies. Detecting planets is immensely difficult, yet astronomers have now identified over 1,000 planets around other stars. The future telescopes planned for this mountain will provide detailed information about these planets, including whether any could support life. If we searched countless places and never found a single trace of life, it would place a profound weight on our species. If we truly are alone, we must take every possible precaution to preserve ourselves. These are enormous challenges for all of humanity, not just astronomers. We are not just discussing distant quasars. We are talking about the fundamental future of mankind. The future observatory site is a short distance from where the largest observatory in the world will stand in a decade. A telescope with a massive mirror will be constructed on the mountain's summit. The technology for such an instrument pushes the limits of current engineering. Visiting this site is a remarkable experience, walking on ground that will be the forefront of astronomy for the next 50 years. The terrain is rough, as a proper road must still be built to transport the giant telescope's components. It is unforgettable to see this place before the mountain peak is altered and the colossal telescope rises. The hope is to remain active in the field long enough to use this incredible instrument. A tower on site measures sky quality, a standard tool used at major observatories worldwide. This future telescope is a revolutionary project. Astronomers have reached the limit for building single-piece mirrors. Any larger requires a segmented design. This telescope will use hundreds of hexagonal segments, like tiles, supported to form a vast parabolic surface. The importance of such a giant telescope is its ability to characterize exoplanets. Current telescopes can discover them, but this new instrument will allow scientists to analyze their atmospheres, determine their composition, and measure their size with unprecedented accuracy. Determining if life exists elsewhere is an immense challenge. Telescopes are the primary tools for searching our galaxy and the exoplanets we discover. The question of intelligent civilizations is more speculative, and we likely will not have an answer for many years. There is optimism that we are at a historic moment, on the verge of discovering Earth-like planets and perhaps other life forms. Building such enormous telescopes is a technological challenge that drives innovation, much like the space race of the 1960s, which led to the moon landing and spawned countless new technologies. By tackling these grand challenges, humanity reaps benefits that improve life for future generations. Perhaps the effort to build this telescope will result in new inventions and goods for our children and grandchildren. The entire human adventure of exploration is a wonderful endeavor. Another future adventure involves human space travel and establishing homes beyond Earth. To explore this, we meet an experienced astronaut who has participated in 2 space flights. One on an American shuttle conducting experiments and serving as a flight engineer, and another to the International Space Station aboard a Soyuz spacecraft, where he was the co-pilot. The space station is permanently inhabited by a crew of 6, following a strict hour-by-hour schedule set by international control centers. A key part of the daily routine is exercise, about an hour and a half each day to counteract the effects of prolonged weightlessness. The experiments conducted cover various scientific fields, including medical research on the cardiovascular system and brain function, requiring astronauts to wear monitoring electrodes. In theory, we understand how to send astronauts to explore Mars, but it requires developing the necessary equipment, technology, and backup systems to support autonomous life on such a long journey. Human nature drives exploration, and eventually people will travel to distant parts of the solar system, conduct research, and return to share their stories. The decision for governments is whether they want to be part of this grand adventure. Latin America has a role to play, as global technological and economic leadership shifts throughout history. There have been times when wealth in Latin America supported Spain, and times when the reverse was true. Latin American governments should promote these projects and support education and engineering enterprises to build a foundation for future participation. As a father, the astronaut believes the key message for children and young people is that knowledge is a tremendous source of enjoyment. Just as understanding art enhances a museum visit, knowing more about the universe makes it more fascinating. This enjoyment and enthusiasm fuel innovation, which is what drives progress. Similarly, in the Mayan jungle of Lacandona, Mexico, a father is passing ancestral knowledge to his son, ensuring their cultural legacy survives in the modern world. The father explains their surroundings, the jungle, and their heritage to his son in their native Mayan language. They are visiting the home of their ancestors. The Temple of the Paintings, built over 1,000 years ago, is adorned with vibrant murals depicting stories, myths, and legends. There are 3 small rooms, each containing a scene that seems to come alive when viewed, transporting the observer back to the time of the Maya. One room shows a celebration for the presentation of a boy who is the heir to the throne. The Maya left a vast legacy of knowledge, though some has been lost over centuries. Preserving it depends on the intention to learn. The community still observes the sky, using celestial patterns to predict the rainy season and determine the best times for planting. At night, they study the stars for guidance. By understanding the beliefs and perspectives of their ancestors, they maintain a connection to their roots. Forgetting this knowledge would mean losing a part of their identity and their connection to nature. Looking to the past can provide valuable wisdom for moving forward. If you found this journey through our cosmic future fascinating, please show your support by subscribing to the channel, liking this video, and sharing it with others who might be curious about the universe and our place within it. Your engagement helps bring more enlightening content your way. Thank you for watching. Your engagement helps bring more enlightening content your way. Thank you for watching.